Look up at the night sky. What you see, stars, planets, the Milky Way, is just the front porch of a cosmic mansion. Let's take a journey outward, leaving Earth behind as continents and oceans blur into a blue marble. We pass the Moon, Mars and Jupiter, watching the solar system shrink to a glittering jewel box. Now we're racing through interstellar space, far beyond Voyager's path at the speed of thought. The Milky Way reveals itself, a swirling spiral of 200 billion stars, our sun just one among them. But our galaxy is only one in a vast city of galaxies. We zoom out to the local group, then the Virgo supercluster, thousands of galaxies bound by gravity. Even these superclusters are just nodes in the cosmic web, immense filaments and voids stretching across the universe. Every point of light is a galaxy, each with billions of stars and untold planets. We're now billions of light years from home, peering deep into the past. The light from these distant galaxies began its journey before humans existed. We reach the edge, not a wall, but the limit of what we can see. The cosmic microwave background, the afterglow of the Big Bang. This ancient light marks the universe as a baby, just 380,000 years old. Beyond it, the universe was so hot and dense that light was trapped in a plasma fog. No telescope can see past this wall of light. This is the edge of our observable universe, 46.5 billion light years in every direction. But is this the end, or just the beginning of a much bigger story? The greatest mystery isn't what we can see, but what lies beyond this ancient curtain. Our journey has only scratched the surface of the cosmic expanse. The universe is far vaster and stranger than it first appears. We stand at the edge of the observable universe, 46.5 billion light-years away. But if the universe is only 13.8 billion years old, how can it be so vast? The answer: space itself is expanding. Imagine galaxies as raisins in rising bread. The dough stretches, carrying them apart. Galaxies aren't moving through space, space itself is growing between them. Light from the farthest galaxies began its journey when they were much closer. But as the light traveled, space stretched, making the distance far greater by the time it reached us. Nothing breaks the speed of light. It's the fabric of space that expands. This means our observable universe is much larger than its age in light years. We live inside a bubble defined by both the universe's age and the stretching of space. It's a mind-bending concept, but it's confirmed by Einstein's relativity and decades of observation. The universe's true scale is shaped by both time and cosmic expansion. Our horizon is not a limit of existence, but a limit of what we can ever see. The expansion of space does more than stretch distances, it isolates us. Because expansion is accelerating, a lonely fate awaits. Beyond a certain distance, the cosmic event horizon, space expands so fast that even light can't reach us from those galaxies. It's like swimming against a current that's always faster than you. The light from those galaxies is trapped, forever unable to reach Earth. Most galaxies are already beyond our reach. We see only their ancient light. As expansion continues, more galaxies will slip beyond the horizon, fading from view. Our observable universe is a shrinking bubble of information. While the universe may be infinite, our accessible patch is finite and getting lonelier. We are living in a great cosmic quarantine, separated by an ever-expanding ocean of space-time. The galaxies we can still see are our last connection to the wider cosmos. The night sky of the far future will be emptier, as galaxies vanish one by one. Our cosmic neighborhood is precious, our only window into the universe's grandeur. We are stranded, but what remains is all the more valuable. Our observable universe has an edge, a boundary of light. But does the entire universe have an edge, or does it go on forever? Scientists consider three main shapes: flat, closed, or open. Measurements suggest the universe is almost perfectly flat. If it's truly flat and infinite, it stretches forever. No edge, no center. But flat doesn't always mean infinite. It could loop back on itself like Pac-Man's screen. In such a universe, traveling straight would eventually bring you back to your starting point, finite but edgeless. Another possibility, a fractal universe, infinitely complex at every scale yet contained within a finite volume. The most tantalizing idea is the multiverse. Our universe is one bubble in a cosmic foam. Each bubble could have different laws of physics, dimensions, or histories. In this view, our universe has an edge, the boundary of our bubble. Beyond isn't nothingness but the space between universes. The question of an edge becomes a question of what lies beyond our cosmic shore. Is our universe infinite or just one of many? The answer could redefine everything we know about reality. The true shape of the universe remains one of cosmology's greatest mysteries. Could we ever find evidence for a multiverse? If so, it must be hidden in our own cosmos. Some cosmologists believe a clue lies in the cosmic microwave background, the CMB, the afterglow of the Big Bang. Most of the CMB is uniform, but there's one large, unusually cold spot. This CMB cold spot is colder than expected and not fully explained by known cosmic structures. One idea, it's a scar from a collision with another universe. In some theories, bubble universes can collide, leaving imprints on the CMB. The cold spot could be a bruise from such a cosmic encounter, a remnant of a brush with a parallel reality. Of course, it could also be a statistical fluke or something mundane. But it remains a tantalizing clue that the universe, or multiverse, may be stranger than we imagine. The search for answers continues, hidden in the oldest light we can see. For decades, scientists wondered if the universe would expand forever or collapse in a big crunch. In 1998, astronomers discovered the expansion is accelerating, not slowing. Something, dark energy, is pushing the universe apart, overwhelming gravity. Dark energy makes up about 68% of the universe. Regular matter is less than 5%. As space expands, more dark energy appears, fueling even faster expansion. This runaway process means the universe's fate is isolation and darkness. Galaxies will slip beyond our event horizon, their light lost forever. Our local group will remain, but the wider universe will become a true void. The nature of dark energy is the greatest mystery in physics. Is it Einstein's cosmological constant, a new energy field, or a sign our theories are incomplete? Whatever it is, dark energy is writing the universe's final chapter. If dark energy grows stronger, the universe could end in a big rip. The expansion would eventually tear apart galaxy clusters, then galaxies, then solar systems. The Milky Way would be shredded, planets flung into darkness. In the final moments, even atoms would be ripped apart. Space-time itself would dissolve, erasing all structure and meaning. The Big Rip is the most complete and terrifying end imaginable. It's a scenario where not just stars and galaxies, but the very fabric of reality is destroyed. The universe would end in chaos, utterly unrecognizable. The idea of a multiverse isn't just science fiction. It's a real possibility in theories like eternal inflation and string theory. Eternal inflation suggests the Big Bang is just one of countless universe-creating events. Each bubble universe could have different laws, particles, or dimensions. In an infinite multiverse, some universes would, by chance, allow for life. This could explain why our universe seems so perfectly tuned for existence. Could we ever know? The CMB cold spot is one possible, controversial clue. Some theories suggest quantum entanglement between universes could leave cosmic fingerprints. The multiverse reframes our reality. Our universe may be just one grain of sand on an infinite beach. The possibilities are as philosophical as they are scientific. Some theories go further, proposing a mirror-image twin universe born with ours. In this anti-universe, time flows backward from our perspective. The Big Bang would be a central point, with two universes expanding in opposite directions in time. This symmetry could explain dark matter, right-handed neutrinos from the mirror universe influencing ours. For inhabitants there, their time feels normal. Our universe would seem reversed. The two universes are forever linked by their shared origin, separated by the Big Bang. It's a wild idea, but it shows how creative science must be to tackle the universe's deepest mysteries. We've journeyed from Earth to the edge of the observable universe and beyond in imagination. The universe can feel like an infinite prison. Expansion has quarantined us, most galaxies forever out of reach. The night sky will grow emptier as galaxies vanish beyond our horizon. Yet, within our cosmic bubble, there are hundreds of billions of galaxies, each with billions of stars and trillions of planets. We've barely begun to explore even our own solar system. The questions are endless. What is dark matter, dark energy? Are we alone? The prison is vast and full of wonders. Humanity's curiosity drives us to explore, build, and imagine. The universe's strangeness is not a reason for despair, but a call to action. Every discovery opens new mysteries. How big is the universe? We don't know. It could be finite, infinite, or one of many. We are small, but our minds and science let us reach for the stars. The quest to understand the cosmos is the noblest journey of all, and it has only just begun. The universe awaits.